So this is after you've done your experiment. What are you going to do with it? Your data. So the first thing you want to make sure of is you try and organize your data into tables. So for example, here we have ascending values, and what you'll notice is whatever you're controlling, your independent variable, is on your left. And so in this case, it would be the mass, and your dependent variable would be your volume. That's what you were examining. A lot of times it's going to be useful to present data in a graph. So for example, the lab we're going to be doing with soda, we're going to present our data in a graph. And again, your independent variable always goes on your x, your dependent variable always goes on your y, and you can see here that we have our mass down at the bottom. Oops, doesn't like me. Here, let's see if it likes me now. There we go. Mass is down at the bottom. That's our x-axis, which is our independent variable. And our y-axis is our volume over here. So, for example, let's just say that we would graph it. And this is what it looks like. A lot of times what we'll do with computer technology, we'll use Excel or Pages or whatever, we'll get a best fit line. And again, that is basically the average of all of them. And it creates a line of best fit, which is actually straight, not like mine. We do not just connect the dots, because that's not what we're looking for here. And then the last thing on this section is just when you look at a graph, how do you tell relationships? And the two major ones that we're going to look at are directly proportional or indirectly proportional. Directly proportional, they have a constant ratio. So if one increases, the other increases. If one decreases, the other decreases. So the classic example of this is if the more you eat, the more you weigh. So that would be one example. When you look at a graph from this, it's going to be a straight line with a it should be straight, not squiggly. A straight line with a positive slope because of that positive relationship. And that's a very common one in science. Another one that's close is an indirect proportion. And this is a situation where as one goes up, the other goes down. So this is a classic example. The faster you drive, so as your speed increases, the time it takes you to get places decreases and goes down. And another example is typically the more that you exercise, typically, I mean, there are exceptions, but you would, usually your weight goes down. When you have your straight line down here, you can relate it to the y equals mx plus b. So this would have an actual equation of the line that you could actually use. Remember, m is your slope, b is your y-intercept, all that kind of stuff. Indirectly proportional graphs look a little bit different. You've probably heard of them in math class. They're called asymptotes. So this is what an asymptote looks like. And what you'll notice is when the x-axis is almost 0, the y-axis is very high, and when the y-axis is close to 0, the x-axis is very high. So those are just some things that are specific to chemistry that we need to know for analysis. Oops, that's not what I want to do. There we go.